All right, good morning, geometry. I just recorded this entire video without actually recording it. Like, I went up here and I went to stop recording after I finished the entire thing, and then the little thing wasn't recording at all. So that sucks. Anyways, I know what I'm talking about now because I just taught this entire lesson. I knew what I was talking about before, anyways. So, anyways, what we're getting into is ways to prove triangles similar. And we've talked about ways to prove triangles congruent, and there were 5 ways we could prove triangles to be congruent. There are 3 ways we can prove triangles to be similar. And 2 of them are going to be the same as congruence, with just one little difference. So the first one I have is the AA similarity postulate. This one we did not have with congruence because remember AAA didn't work. But if we have AA, so if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So I have my 2 sets of congruent angles. Remember, the angles are congruent, not proportional. So I have 2 sets of congruent angles on these 2 triangles. And with AA, we only need to know 2 because if we know 2, we automatically know the third because of that triangle sum theorem. So let's say, for example, this is like 45 degrees and this is 65 degrees. Then that means this is also 45, and this is also 65. So I know that because of that triangle sum theorem, that 45 plus 65 plus, we'll call it x, which is that missing angle measure, is going to equal 180. 45 plus 65 is 110. Plus x equals 180. Subtract 110 from both sides, I get x equals 70. So there's 70. That's why we don't need to know all 3 angles. We just need to know 2. And if 2 are matching up, then the third one is automatically going to match up as well. And yeah, that's how to prove them similar using AA. Then we have SSS. So if corresponding sides of 2 triangles are proportional, then the 2 triangles are similar. And we need all 3 side lengths here to be proportional. And remember, to prove that they're proportional, we just have to do those proportions, the fractions. So to figure out which ones are going to be corresponding, I'm going to take the short side and match it up with the other short side. So the short side of the first triangle was the 8. The other short side of the second triangle was 2. So that means 8 over 2 should equal, well, the medium side length is this 16. The medium side length of the other one is the 4. And that should be equal to the 24, which is the long side length, over 6, which is the long side length. And actually, if you look at these triangles, you'll see that they're not real triangles because 2 plus 4 equals 6, and they would have to be greater than 6 for it to be a real triangle. So these aren't actually real triangles. But regardless, 8 over 2 reduces to 4 over 1. 16 over 4 also reduces to 4 over 1. And 24 over 6 also reduces to 4 over 1. Since I got the same value each time, then I know that they are 2 similar triangles. And SSS is one of them that was a congruence theorem as well, but the SSS similarity theorem, it's exactly the same, except it has this word proportional. On the congruence theorem, it had congruent. So if all three sides are proportional, then they're similar. If all three sides are congruent, then they're congruent. All right, next I have SAS, which is the third similarity theorem. Well, the SAS and SSS are theorems. AA is a postulate. So let's see. If an angle of one triangle is congruent to an angle of a second triangle, so the angle is going to be congruent, and the lengths of the sides including those angles are proportional, then the triangles are similar. So I need the side lengths to be proportional, and I need this angle between the two sides. It has to be the angle between the two sides. It can't just be a random angle in that triangle. It has to be the angle between the two sides. So that angle has to be congruent to the other angle. Then we're going to know that they're similar. So let's see. In this first triangle, I have 10 and 15. So 10 is my shorter side length, and I'm going to divide that by the shorter side length of the other one, which is 2. And then 15 is the longer side length. I'm going to divide that by the longer side length of the other one, which is 3. So 10 over 2 is 5 over 1. 15 over 3 also reduces to 5 over 1. Since 5 over 1 equals 5 over 1, these are similar by SAS. Okay, I was just looking at something. Okay. So there we go. Again, SAS and SSS, the only difference between the similarity theorems and the congruence theorems is that the sides have to be proportional, not congruent for similarity. The angles are always going to be congruent. All right, and then we have some problems with overlapping triangles, and we saw a problem with overlapping triangles on Friday that I discussed how to do. But here's how we know that these overlapping triangles are going to be similar. So on this first one, we're not given any markings except for the parallel lines. And if these two lines are parallel, well, then I know that this side, which intersects both those parallel lines, is basically a transversal. So these are two parallel lines that are now cut by a transversal, which makes this angle and this angle into two corresponding angles. And likewise, likewise, this side of the triangle also intersects both those parallel lines. Therefore, these two angles are going to be corresponding angles. Now I have this small triangle off the tip, and then I have this big triangle, which is the entire thing, and both those triangles share two angles. Therefore, they are similar by A. All right, next, I have this triangle, and on this triangle, I have right angle marks, and I know right angles are always going to be congruent to one another, but I don't see anything else that I can use here, except for this specific corner of the triangle. So this corner is shared by both the small triangle and the large triangle. Therefore, that corner is going to be congruent to itself. So now the small triangle has this angle that's congruent to itself plus the right angle, and the large triangle has this angle that's congruent to itself plus the right angle. Therefore, they have two congruent angles, and they are similar by AA. And this last set, these aren't overlapping, but they do have something that we're able to conclude. So we are given these two congruent angles here, and we also have these corners that touch there. And if the corners touch in a manner similar to this, it's pretty safe to say that they are going to form vertical angles. And remember, vertical angles are angles that are across from each other when two lines intersect. And vertical angles are always going to be congruent to one another. Therefore, if I just look at one triangle, I have two vertical angles within one triangle, or two, not vertical, two congruent angles within one triangle. Therefore, once again, these are similar by AA. All right. Continuing on, we have some examples, and these examples, pay attention during them because this is pretty much the exact assignment that you guys are doing today. I believe today's assignment, it is 8 problems that look like this, and then 4 problems that you have to set up a proportion and solve for x, just like we were doing on Friday. And on those 4 problems, you should not be getting decimals. I'm just telling you now, all of the answers will be whole numbers. Okay, so we want to determine if the triangles are similar, and if similar, state how, and write a similarity statement. Okay, so first I have this triangle EFG and this triangle RTS. I see 2 side lengths marked on each triangle, and I see 1 angle marked. And that angle is between the 2 marked side lengths. Therefore, I may be able to conclude that they're similar using SAS. So let's see. The short side length of the first triangle is 3, and the short side length of the second triangle is 9. The short side length of the long side length of the first triangle is 5. The long side length of the second triangle is 15. 3 over 9 is going to reduce to 1/3. 5 over 15 also reduces to 1/3. Therefore, since 1/3 equals 1/3, we are able to say that those 2 side lengths are proportional, and since the angle between the side lengths on both triangles is congruent, then these are similar by SAS. And we also want to write a similarity statement. So I will say triangle, I'll call the first one EFG. That will be similar, make sure you're using a similar symbol there to triangle. So E is at the tip of the short side. The other one at the tip of the short side is that R. And we know angle F is congruent to angle T, so T comes next. And then, no, not G. G is going to be congruent or similar to S. So there we go. EFG is similar to RTS. Okay. I do apologize that some of these letters aren't very clear. That's W. It took me a while to figure out that was a W. Anyways, I see no angles marked on either of these triangles, but I do see 3 sides marked with measures. So hopefully I'm able to conclude using SSS. So let's see it. The short side is 22. The short side over here is 16. So 22 over 16 should equal the medium side, which is 28, divided by the medium side over here, which is 20. So 28 over 20. And that should equal, let's see, 35, which is the long side, over 25, which is the long side. So 22 over 16 reduces to 11 over 8. 28 over 20, if If I divide both those by 4, I get 7 over 5. And 35 over 25, if I divide both those by 5, I get 7 over 5. So I got 11 over 8 equals 7 over 5 equals 7 over 5. That's not true. 7 over 5 equals 7 over 5. But since the third set didn't match up, then these are not proportional. All three sides need to be proportional. So since I only knew the 2, then I'm not able to say that these are similar. And if they're not similar, we just leave it at that. We're not going to write a similarity statement because they're not similar. All right, so on this next example, I'm given 3 angle measures, and they're all different angles. However, I am able to figure out some other angles here. So I know that, dang it. All right, there is 2 lines that cross each other. They form that 42-degree angle right there, meaning this angle here is also going to be a 42-degree angle because we have some vertical angles that were formed. Let's see. Also, looking at this triangle ABE, I have 2 angle measures there. I'm able to figure out the third using the triangle sum theorem. So I can say that 53 plus 42 plus the measure of angle E is going to equal 180. Okay, I want to combine my like terms. So 53 plus 42 is 95, plus E equals 180. Subtract 95 from both sides. And I'm going to get E equals 85. So that means this is 85. And C is also 85, which is perfect because now I know that this angle ABE matches up with this angle DBC. And I know that E is congruent to C. Therefore, I'm able to conclude that these are similar by AA, angle-angle, because I know about 2 similar angles, or 2 congruent angles within each triangle. So my similarity statement is going to say, I'll call it triangle ABE is similar to, well, A was 53 degrees, and since we know that this is 42, we know that D has to be the one that's 53. B is 42 on both of them. And then the last point on the other triangle is C. So ABE is similar to DBC. Okay. On this one, before we get started, that's the letter Y. This is a P. I thought it was a question mark at first. All right. So let's see. I have some overlapping triangles here. And I don't see any angle measures, but I do know that this angle P, which is shared by both triangles, is going to be congruent to itself. So I could actually use SAS because I know the measures of 2 sides and the angles between them. But I also know the measure of the third side, so I'm actually going to use SSS here. We could use either one, though. So let's see. I know that this side QR is going to be proportional to this XY. So, or I mean not proportional. Yeah, it should be proportional. So, yeah, QR and XY. And let's see. I want QP and XP. And QP is not 6. It is 6 plus 18. 6 plus 18 is 24, and xp is 18. And likewise, I'm going to have rp, which is in the big triangle, and yp, which is in the smaller triangle. So rp is not 5, it is 5 plus 15, which is 20, and yp is 15. And hopefully these all reduce to the same number. So 16 over 12 is 4 over 3. 24 over 18, I divide both those numbers by 6, I get 4 over 3. 20 over 15, divide both those numbers by 5, I get 4 over 3. Since I got 4 over 3 times, then these are all proportional sides. Therefore, I'm able to use SSS, side, 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 to say that these are similar triangles. So let's see. My triangle, we'll say QPR is similar to triangle. Let's see, Q and X are along the same side. And then P is congruent to P. And then R and Y are along the same side. So QPR is similar to XPY. Okay, side, side, side. Okay, on number 5, I have, the only markings I'm given are some parallel lines. So I know KM is parallel to JN, and that's going to make this JL a transversal. So I know that this angle J would be congruent to this angle K because they are corresponding angles. Likewise, I know LM is parallel to KN, so that tells me that this angle K is congruent to this angle L. And now, if I'm just looking at one triangle, I have two angles that I know are congruent within that one triangle. I don't know about any sides. I know sides are parallel. I don't know about congruent. But since I have markings on two of those angles, I'm able to say that these are similar by angle, angle. And my similarity statement, let's see, I will say triangle KLM is similar to triangle. Well, K had one congruence marking, so does J. L had two congruence markings, so does K. And then the last point would be N. So KLM is similar to JKN. This is an example of a problem where the same letter is not going to be in the same position in two different triangles. So we can see that K is the first letter of the first triangle, but the second letter of the second triangle. And it's just because of the way the triangles are. It's because K is not a shared angle, or that angle at K is not congruent to itself. It's formed by two separate angles that are congruent to something else. So, yeah. Regardless, this is our statement. And finally, the last one. So this one, I see two sides. I see this FD and I see this ED. I'm not given FE or TS, but I do know that this angle D has to be congruent to itself. Therefore, if these are similar, I'm going to be using SAS because I would have two sides in the angle between them. So let's see. My big triangle, this FD is not just 30, it's 30 plus 35. So that would be 65 over TD, which is 35. And that should be equal to ED, which is not 20, it's 20 plus 24. So that should be equal to 44 over, and then SD is 24. I want to reduce these fractions. 35 or 65 over 35 is going to reduce to 13 over 7. 44 over 24 is going to reduce to 11 over 6. 13 over 7 doesn't equal 11 over 6. So we're not able to say that these are similar triangles. Therefore, they're not similar. Okay. So before this video ends, I would like to say that, well, like I said, today's assignment is going to look basically the same as this, as these last 6 problems, plus some of what we did on Friday. As for Wednesday, so we don't have school tomorrow, and so tomorrow being November 3rd, I'm sure some of you guys are watching this on November 3rd, which is fine, but we don't have school on November 3rd, meaning we don't get to review for our quiz on Wednesday. Therefore, there won't be a quiz on Wednesday. We will have an assignment, some sort of summative assignment, but it's not going to be a full quiz. It's not going to be anything too difficult, and don't stress yourself out trying to study for something because there's nothing to study for. With that being said, I will see you guys Wednesday.